Welcome to the third installment of 1.2 Solving Multi-Step Equations. In this lesson, we will focus on solving real-world problems, modeling them with an equation. And modeling is a discipline in math where you are going to apply this abstract set of ideas to a real-world scenario. So this is where we're finally going to see some application of our skills that we've been building, writing and solving equations, and having significance for what the variable stands for. We will determine success when we can write an equation to model a real-world problem, to solve it, and then explain the solution's significance in the context of that real-world problem. So let's review some of the prerequisite skills for today's lesson. Remember that the steps for solving multi-step equations are to simplify the parentheses in one of two ways, either distribute and then pop the parentheses, or treat the parentheses like a term and then isolating them. So then you could divide by its coefficient. Of course, you're always combining like terms when possible. And then lastly, you're isolating the variable as a single copy using inverse operations. So in this first review example, we're going to see that this term, this parenthesis, can be treated like a term. So we're going to get that 4 to the other side using its inverse operation of -4. And then we bring down our regular -3 and then a plus 2, unchanged. I'm hoping that on the right-hand side, we get a number that's divisible by 3, and sure enough, -8 minus 4 is -12. So now I could divide both sides by the coefficient of the parentheses and never have to distribute and make the problem longer and more complex. So these divide out to 1, and then we have on the right hand side a negative divided by negative is a positive. So now we have inside of our parentheses just a plus 2, and the parentheses go away because we don't need to group that separate from anything anymore. And then 12 divided by 3 is 4. And last step, so we want to get this 2 to the other side using its inverse operation of -2. To both sides, we're subtracting that value. And so then for our final answer, we get a is equal to 2. Now you could have distributed to each of these terms. That would just have made the problem longer and harder. So be on the lookout for this approach, treating the parentheses like a variable to isolate. Looking at this example, I will definitely have to distribute because I have more than one of these grouping symbols and they're not the same inside, so I can't combine their coefficients. So let's get underway with those distributions. And these arrows represent products, and I'm going to write them out as follows. The 14 is going to stay where it's at, and now I got 3 times y, and then that positive 3 is then going to times by that -2. Now, when we go to the next distribution, that negative sign will go to each one. So now we will have -2 times 1, and then that -2 again, including its negative, will go and multiply by that -y. So let's combine some like terms after we simplify some products. So we're just going to have 3y there, positive times a negative makes that -6, negative times a positive makes that -2, and then a negative times a negative over here, that's going to go positive, and that will give us a positive 2y. So our like terms, we got these terms with y, and then we have these terms that are constant on the same side, so let's combine those first. So 14 is just waiting. Now 3y plus 2y, so it's adding 3 and 2 for a sum of 5y. And then we have the -6 minus 2. That's like adding, but because they're both negative, the sum is going to be negative, and then 2 plus 6, which is 8. And that needs to go join its like term on the other side of the equation. So we use the addition property of equality, that what you do to one side, you do to the other, using its inverse. And so then we have 8 plus 14, which is 22, is equal to 5y. And then our last step then is to divide both sides by 5, because we want y by itself. And so our final answer is going to be y is equal to 22/5. So now we're ready to solve 1.2 Part C, writing multi-step equations. So remember, what we're going to learn is how to model real-world problems with an equation. And we're going to determine our success by creating those models, solving them, and then explaining the solution in its context. So here's our example where we're going to use this table to find the number of miles you need to bike on a Friday so that the mean number, or simple average, bike per day is 5. So you started out at the beginning of the week with this goal in mind, and you started off pretty strong, and then Wednesday life just happened. You just couldn't get out and ride. You rode strong on Thursday, and then here is where we're trying to decide what do we have to do for the last day of the week to keep and reach our original goal. So what we want to do here is realize that the average is the sum of all the numbers divided by however many numbers are in the sum. So we're going to write it like this. We're going to write 3.5 plus 5.5, and then plus 0 plus 5, and then plus, I'm going to use a variable here, and because the context is miles, I'm just going to put an m, and then that's all divided by the number that are there, 1, 2, 3, 4, 5. So then divided by 5, and then this will equal what it has to be in order to get to biking each day as an average of 5. So that's the end result over there. So then we can either do this arithmetic in our head and do 3.5 times 5.5. So the 0.5s make a 1, with a 5 is a 6, with the 3 is a 9. And then over here with the 5 makes that 14. So 14 plus m in the numerator divided by 5. Then that equals 5. So what we want to do from here is realize that the numerator and denominator are as simplified as possible. And that means that we have to undo this division, because right now this fraction bar is like a grouping symbol, and we want to ultimately get that m by itself. So let's get that 5 to the other side using its inverse operation of multiplication. That's a multiplication dot, and what you do to one side you do to the other. And so now these will divide out to 1, leaving us on the left hand side with 14 plus m, and on the right hand side the product of 5 and 5, which is 25. Now we subtract 14 from both sides because we're going to combine like terms with those numbers, and then we have that m is equal to the difference of 25 and 14, which is 11. So 11 miles, mi for short, is how many we need to bike on Friday in order to average a distance of biking 5 miles per day. So that's a neat trick that you could also use for, like, hey, what do I need on the last grade of the marking period to get a certain average on your report card? So in this example, we're going to use this given formula that relates the nozzle pressure N in pounds per square inch of a fire hose and the maximum horizontal distance the water reaches in D in feet. And so our question is, how much pressure is needed to reach a fire 50 feet away? So when you're given an example that includes a formula, the first thing that you should do is write that formula down, because that is going to give you your bearings for how you proceed with the problem. And now you scan the problem for any given information, and we're told this value right here, and that relates to pressure. So that is going to go into nozzle pressure N in pounds per square inch. So that's right here. So we'll make that substitution. And we'll simplify this product. Half of 50 is 25. And then the sum of 25 with 26 gives us, oops, I'm sorry. So I substituted in the value the wrong way. This N being the pressure is kind of confusing, but it's how the actual formula is in like the database of formulas, if you will. But really, I would say that should be P for pressure. And then I don't think I would have had that confusion. But yeah, 50 feet is going to be distance. So that's going to go on this side of the equation. So sometimes that happens. Just make sure that when you get down to the end that you're really considering what you're given and does it make sense with how you used it and the result that you got. I was about to get a result that was D equals 51 feet. And I was like, oh no, I need something that is pressure. And then that's when I realized my mistake. So it happens. We're going to go back to the drawing board. And so I'm going to substitute into this formula, this 50 feet. And that is going to be the D value. And now how I'm marking it up is a really good idea to help keep track of your information. So 50 feet goes on the left. And then it's half or 0.5 times n, and then plus 26. So now we're ready to go. So I'll subtract 26 from both sides, combining these like terms here. So the difference of 50 and 26 is 24. And then that equals, now I'm going to switch that up because I could have that as a n on 2 because 0.5 is the same thing as 1/2. And that is very helpful because now I could just multiply by 2 to both sides of the equation. So that'll divide out to 1. So then we have 48 is equal to n. So in other words, it's 48 pounds per square inch or inches squared. That is what we need in order to put that fire out 50 feet away. Okay, in this example, our school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After we pay back the loan, we have a profit of $100. So how many people attended the play? Well, it first helps with a problem like this, in order to get your bearings, to write it out in abbreviated words. So let's see here. We have $4 per person. And we borrowed $400. And then after we paid back the loan, it has a profit of $100. Now, I usually like to start with something that is like what it is equal. So we know at the end, it is equal to 100. So now that that's out of the way, and we borrowed 400, so I know I'm going to subtract that from everything. And it is 4 per person for admission. So like 4T per ticket sold, we make $4. And then after we subtract the 400, we'll have 100 left over. So let's solve it. So we're going to get the T isolated first by combining the numbers. And so this 400 needs to go to the other side using its additive inverse. And that's now a 0. And so we get on the left-hand side, the sum of 105 and 400 is 500. And that equals 4t. And then we divide both sides by t's coefficient. And so t is equal to, this is going to go in evenly 400 times with 100 left over. And then that'll be 25 remaining. So 125 people attended the play. And so notice this variable has meaning in this context, and in the end, when we find out its value, we could add a unit to it, so then it gives flavor and significance to what is happening in this real-world example. So let's wrap it up. So what we learned here was how to solve real-world problems by modeling those problems with an equation. And we have determined our success as creating that equation to model the real-world problem and then solving it, and then, most importantly, correctly interpreting the result within the context of that real-world problem. Remember always that steps for solving multi-step equations are first to simplify the parentheses, either through distribution or isolating the parentheses like a term. And then, of course, you're always trying to combine like terms when possible and using inverse operations to move them from one side to another as you isolate the variable.